Hi students, good evening. In this video we will discuss queue and its implementation of queue. So in last session or last class we discussed that queue is a linear data structure where insertion is possible from one end and deletion is possible from other end. That is, deletion is possible from this end and insertion is possible from this end. So insertion is possible from this end. So the insertion possible end we call it as rear end, and this end we call it as front end. So this end we call it as front end. So from front end deletion will be performed, that is del operation will be performed from front end, deletion operation will be performed from front end. Now we discussed that queue follows which method? FIFO method, that is first inserted element will be deleted first. In queue both the ends are open, one end for insertion, the other end for deletion. Now we discussed in the last session that in queue there are two pointers we use, one is front and the other one is front and rear. So front points to first element of queue, and rear points to last element of queue, Now some of the important points we need to remember, that is when queue is empty, so what we need to do? So whenever queue is empty, the position of front will be 0 and rear will be -1. So here whenever queue is empty, the position of front will be at 0 and rear will be at -1. So when queue is full, what is the position of front and rear? So here we will not consider the front position, we will check only the rear position, that is rear will be at size -1. We call like this one, if rear is at size -1, queue will be at size -1. Sorry, when rear is at size -1, queue will be full. And here we need to remember one more very important point in queues is, so if both front and rear are pointing to same location, or same element, how many elements will be there? Generally front points to first element and rear points to last element. If they are pointing to same element, there will be only one element. So there will be only one element in queue. Then if we delete that element, how many elements will be there? 0 elements. If we delete that element, queue becomes empty, that is there will be 0 elements. When there are 0 elements, what should be the position of front and rear? Front should be 0 and rear should be -1. This one more additional point we need to remember, this one. This is very important in queues. If there is only one element, in delete we need to remember, while performing the delete operation we need to write the code for this statement also. Okay, now let me delete this code now. So let me explain you about operations on queues. What are the different operations possible on queues? One is insertion, first one. Operations possible on queues. What are the operations we can perform? First one, insertion. Then second, deletion. Third, display. We can perform these three operations: insertion, deletion and display. Now let us discuss about insertion operation. Similar to stacks, here what we need to do here is void insert int n. That is, insert function will take the parameter and delete function will return the value. So here whenever we are inserting in queue, so what is the position? What we need to do? Insertion rare plus plus, increment the rare pointer and insert the element into the queue, that is queue of rare equals to n. Then you can display one message, element inserted, that is printf element inserted. So whenever we are inserting, we should increment the rare pointer, then queue of rare equal to n, element inserted. Similar to stacks, here also we need to check that if rare is at size -1, if rare reaches to last location, it is not possible to insert the element into the queue. So we need to check that condition first, that is, if rare equal to size -1, that is, if rare reaches to last location, so then it is not possible to insert. So queue overflow, just display the message queue overflow, because already rare is at size -1 and it is not possible to insert. So whenever we are inserting an element into the queue, first we need to check this condition. If rare equal to size -1, it is not possible to insert. Otherwise, if rare is not at size -1, at least one element we can insert. So rare will be incremented, that is rare plus plus queue of rare equal to n, element inserted. Now initially this queue is empty, we can call that this queue is empty. Now what we can do here, let us take, now whenever we insert an element, now let us take this example. Initially this is queue, let us assume this is queue. So front is at 0 and rare is at -1. So whereas in some books we see that both front and rare will be at -1. So in such case what will happen? Whenever we are inserting the first element, both will be incremented. Okay, so here in this case I am taking front will be at 0 and rear will be at -1. So now I want to insert one element called 10. I want to insert into the queue. So rare, what is the position of rare? -1. -1 equal to size -1, false. Rare plus plus, so rare value will become 0. Rare, that is, it is pointing to the index. Q of 0 equal to n. The 10 will be stored in this location. 10 will be stored here. Now again I want to insert one more element, that is n, that is, let us assume I want to insert 20. So rare, what is the position of rare? 0. 0 equal to size -1, false, goes to else part, rare plus plus. Rare value will be incremented. Now q of 1 equal to 20. Now 20 will be stored into the queue. In this way we can continuously insert the element until rare reaches to size -1. Once rare is at size -1, so this condition becomes satisfied, it displays the message queue overflow. This is inserting an element into the queue. Now let us check deleting an element from queue. The second operation, that is delete. Now, so in order to delete an element, so what should be the condition? There should be at least one element in the queue. Now let us take, so here I will take, in order to perform the delete operation, I will take 3 elements. So the number of elements in the queue are now 3 elements here. Now, so now what is the position of front? 0. The position of rear is front is at 0 and rear is at 2, because front points to first element of the queue and rear points to last element of the queue. Now let us perform delete on this queue, delete operation on this queue. Now here delete operation on queue, right. Okay, now let us check delete. So when we can delete operation. So here delete is a keyword in C++. So we use a function name called del. Okay, now here the return type of this function is integer. It will return the value. Deleted element will be returned to the caller. Now the first condition what we need to check here is, here remember whenever we are deleting front plus plus, whenever we are inserting rare plus plus into the queue. Now the first condition we need to check whether there are any elements available or not. So first check the condition. If rare equal to -1, how many elements will be there in the queue? 0 elements. That is, if there are no elements, is it possible to delete? No. So directly display the message printf queue underflow. So this function has to return one value like stacks. So here also we will return -1. That is, if queue is empty, -1 will be returned to the caller. Otherwise, else, how to delete? The simple condition, directly you can write here return queue of front plus plus. Return queue of front plus plus. Now let us check this condition. Okay, so remember here we need to add one more statement that I explained you. Whenever there is only one element, so that I will include later. Now let us delete. So call the delete function rare. What is the position of rare? 2. 2 equal to -1, false. Return queue of front plus plus. What is the position of front? 0. Front plus plus means front will move to 1, and what happens? This 10 will be returned to the caller. So this 10 will be returned from where the function has been called to that location it will return. Now let us call this function once again. Once again, if delete function is called rare, what is the position of rare? 2. 2 equal to -1, false. Goes to the else part, queue of front plus plus. So what is the position of front? 1. Now front will move to this location and this 20 will be deleted. Now if you run the same program, front will move to next location. It leads to a problem. So I told you in queues we need to remember one point. What is that? If both front and rear are pointing to same location, how many elements are there? There is only one element. If you delete that element, queue becomes empty. So here we need to check the condition. Else if front equals to rear, else if front equal to rear, there will be only one element in the queue. If front equals to rear, there will be only one element in the queue. So what we do here is x equal to queue of front. So that element we are storing in x. So x need to be declared here. If you are using x, that variable should be declared here, int x. Then after that, if front x equal to queue of front, then after that, so what should be the statement? Front, when if we delete that element, queue becomes empty. When queue is empty, what should be the position of front and rear? Front equal to 0 and rear equal to -1 and return x. This x should be returned to the caller. This x should be returned to the caller. That is return function. That is delete function. We use delete function here. So now there is only one element, rear equal to -1, false. Front equal to rear, yes. So what happens? So this one element will be deleted. So now both front and rear will point to 0 and -1. So front will move to 0 and rear will point to -1. Rear will point to -1. Then return x. The deleted element will be returned back to the caller. That is delete function. In pop, only this statement will not be available in stacks. So only in queues This part is very important. That is, if both front and rear are pointing to same location, there is only one element, that element should be deleted. That is about delete function. Now next we will discuss about display function. So in the display function, what we need to do here, now let us assume that here we have three elements like 10, 20 and 30. So front is pointing to this location and rear is pointing to this location. Now front is pointing to this location and rear is pointing to last element of the queue. Now let us see the display function. So let me delete this part. So let me delete this part. Right. So now what operation we need to perform? Display. So here we will display from first to last, first element to last element we will display. So for display the logic is very simple ma. For I equal to front, from front, I equal to front, I less than or equal to rear, I plus plus. Will display the elements from front to rear. Simply you can use directly printf %5d comma q of I. This is display function. So I equal to front is pointing to 0, then rear is at 2, 0 to 2 elements will be displayed. So front to rear, whereas in stack we will display from top to 0, whereas here from front to rear will be displayed. So here we need to define the queue function, void display, then check the condition here, if rear equal to size minus 1, if rear equal to size minus 1, display the message queue is empty. Printf queue is empty. Else then display the elements of queue. Else display the elements of queue. So elements from front to rear will be displayed. That is about queue. Now let us check the execution of this particular program. Here I have already developed this program. Now let me remove this part. So here this is not stacked, this is queue. The size of the queue is 5. Here I have defined a macro has defined size 5. Let me explain this each statement. Defined size 5 int queue of size, declaring a queue. Actually it is an array, so we are treating it as queue. 2 pointers, initially no elements, so rear equal to -1 and front equal to 0. The function definitions are insert will take parameter, delete will return the value, display function. So do while loop I am using operations on queue, 1 for insert, 2 for delete, 3 for display, 4 for exit, accepting the choice from the user based on the user's choice. If user's choice is 1, then accepting the element from the user, insert function will be called. Then if user choice is 2, delete function will be called. The returned value will be stored in X. So here if there are no elements, -1 will be returned. If there is an element, so that value will be returned. So that element we are displaying it onto the screen. Display directly will call exit to terminate the program. Now you can see here while 1 is a infinite loop. Insert function, if rear equal to size -1, queue overflow, else rear plus plus, queue of rear equal to 1, element inserted. Then delete function, so if rear equal to -1, queue underflow, -1 will be returned. Now if there is only one element, if front equals to rear, q x equal to q of front equal to 0, rear equal to -1, x will be returned. Then otherwise if there is more than one element, q of rear plus plus, return q of rear plus plus. Display you can see here, if rear equal to -1, q is empty, elements of q are front to rear will be displayed. Now so let me run this program, save this program once, compile and run the program. Now you can see here queue with operations on queue. So insert delete, initial just now I have started, so there are no elements in the queue. Queue is empty, it displays the message queue is empty. Now, so 2 for delete, so again you perform the operation delete. 2 for delete, are there any elements? No elements, so it displays the message q underflow, displays q underflow. Now here so 1 for insert, so I am inserting element called 10. Again 1 for insert, 20 I have inserted. Again 1 for insert, 30 I have inserted. Now how many elements are there in the queue? So if this is a queue, there are 3 elements are stored into the queue. So 3 elements are stored into the queue. The elements here are, let us assume those elements are, so 10, 20 and 30. Now what should be the position of front and rear? So front will be pointing to the first element and rear will be pointing to last element, and their index numbers are 0, 1, 2, 3 and 4. Right. Now you can see here there are how many elements in the queue? 3 elements. Now let us enter choice 3. What are the elements? 10, 20, 30. So this line is for separation purpose. 30. Now again I want to insert one more element, 1, so 40. Again I want to insert one more element, 50. Now what is the position of front and rear? Let us check here what happens. Want to insert one more, inserted one more element, that is 40 is inserted here and 50 is inserted here. Now how many elements are there in the queue? There are 5 elements in the queue. There are 5 elements in the queue. Now front is at first location and rear is at last location. Front is at first location and rear is at last location. Now let us check, enter your choice, that is 3. So 3 is for display. So what are the elements? 10, 20, 30, 40, 50. Now let us delete one element. 2 for delete, 10 is, so 2 for, enter your choice. So deleted element is 50. Sorry, 2 for delete, deleted element is 0. 2 for delete. Okay, sorry, let me check once. So if rear equal to -1, q of front, sorry, this is not rear plus plus, this should be front plus plus. Right, let us execute this program. So let me insert 5 elements quickly, 10, 20, 30, 40, 50. 1 for insert, 60. What happens? Overflow. Q overflow, it displays. Now 2 for delete, so 3 for display, you can see 5 elements. 2 for delete, 10 is deleted. Again 2 for delete, 20 is deleted. So here you can see 20 is deleted. Deleted element is 20. Next 2 for delete, 2 for delete, 30 is deleted. 2 for delete, 40 is deleted. Now 3 for display, how many elements are there? Elements of Q are only one element. Now 2 for delete, that 50 is also deleted. Now again if you try, Q is underflow. 3 for display, Q is empty. 4 for exit. Okay, thank you. So if you like the video, please say, share and subscribe the video. Thank you. We'll see you in next session. Thank you, ma'am. We'll see you in next video. Bye.